All right, let's get started. Welcome to the session on core software design principles. We're going to talk about certain principles. The principles I'm going to talk about are not really new. However, I find that these principles actually are pretty timeless. I've used them for quite a while, and I continue to use them almost every single day. So I really value these principles a lot. So we're going to talk about some design principles, but before I talk about the principles, I want to talk about why I want to talk about these principles. Oftentimes, as programmers, architects, designers, what do we normally do? We want to use design patterns. We have this strong desire to apply design patterns oftentimes. But there are two problems when it comes to using design patterns. One of them is trying to figure out what design pattern makes really good sense is really hard. And we struggle to really figure out what design pattern may apply. And even worse, if we choose a wrong pattern in a particular context, it might actually become problematic. It may actually complicate things and make things even worse. So we have to be very careful about what design patterns we want to use. Well, this is where I think design principles play a really nice role. Because it turns out every single design pattern has a design principle behind it. And if we think about what design principle is behind a design pattern, we can then look at the design problem we have on hand and decide if that particular problem has very similar pattern principle behind it. If the principle behind a particular problem or a force behind a particular problem is a particular design principle, and if that's the same principle that's behind a design pattern, then we can know that maybe there's a really good match between them. So when I look at design patterns, I often ask the question, what design principle plays a really good role in this particular context? That's one of the reasons I really want to talk about design principles. I consider these to be much more valuable and leads to a better use of design patterns in general. Best time to ask questions or make comments is when you have it, so you don't have to wait till the end. Anytime is a good time for questions. Just raise your hand, start speaking. I'll repeat your question and then we'll discuss it. So don't wait until the end. Anytime is a good time. So let's get started. So where do we see these design principles being used? Well, I see these principles being used almost constantly anytime we are coding, anytime we are thinking about design concerns. I see these principles play a very vital role in what we do. These are pretty timeless, like I said. I see them very often being used. And one of the reasons I really like to use them is that they actually provide for a better extensible design and solves a lot of issues that we would normally run into in design. That's one of the really good things. So when do we really use these design principles? I like to divide the design into two parts. And the way I view design is I divide them as what is called a strategic design. And then, of course, there is a tactical design as well. So a strategic design is a design step where we are thinking about the big picture. We are thinking about how do we go about looking at layers of architecture all the way down to what are some of the major classes we would have in the system. I look at a strategic design as more of a vision or a direction. Oh, this seems to be a good idea. Maybe these are the classes I would consider. The strategic design is something that tells us which direction to move in. It's not set in stone. I don't want ever to have a strategic design that doesn't change. A strategic design should evolve and change as our understanding of the system evolves and changes as well. That becomes extremely important. Once I come up with a strategic design, I often then really look into it further and go into what is called a tactical design. A tactical design is where we get into finer grained details. This is when I'm interested in the specific details about a class, the methods, the signature of the methods, and all the other details associated with it. That's basically what I'm doing when it comes to a tactical design. When it comes to a strategic design, things you normally may use during this phase are things like domain-driven design. So where we are talking about how to apply different concepts from the domain, focused on the ideas behind the bounded context and all the other things that domain-driven design offers, I often tend to focus on some of those issues when it comes to strategic design. When I come down to the tactical design, I often use TDD, or test-driven development. So domain-driven design, useful for strategic design. whereas a TDD approach is a lot more tactical in nature. And this is where I often use the design principles quite extensively during this phase of tactical design, because I feel that this is when we can really apply some of these finer grained design principles and make good use of them. So when you look at design broadly, it is important for us to consider these two parts. Now here comes one of the real big problems though. In the past, what we did was mostly waterfall development. And what did we do in the waterfall development? In the waterfall development, we had some really nice, interesting stages. We did a requirements gathering phase, then we did analysis, then we did design, and then we did implementation, and then we did this wonderful thing called testing, which is often left out to the real users, right? So the point really is we kind of separated these into phases. Now, obvious question here is, what's wrong with waterfall? Well, if you really think about it, the problem with waterfall is that you would go on with these phases of, analysis and design, but by the time you come down to writing code does something wonderful that any of the other phases normally don't. And that is when you write a piece of code, you can compile it. When you compile a piece of code, you can run it. And when you run a piece of code, you can complain about it. And those kind of feedback don't exist in phases before this. So the problem with waterfall is, I'm going to say there is a time in every project when you can change the direction and make it better. But that opportune moment very rarely comes towards the end of the project. I remember working on a waterfall project in my early part of my life, and I remember my boss telling one day, and actually he blurted this out, he said, this project was going so well until these damn programmers got together. Because until the programmers got together, we were on schedule. Everything was going well. But these programmers get together and start writing code, and they ask bloody questions. How does this work? How does that work? That doesn't make sense. And so if we can get rid of the programmers, we'll always be on time on projects, right? Well, that is one of the problems with waterfall approaches. The feedback loop comes very too late. But if you really think about it, we are all agile now. So this is great news. So what does agile mean? No design. Let's just code it, right? Well, how does that work? Not so well, but that's okay. We celebrate agile still. We're so happy, right? Well, this is as dangerous as the other approach. So if you really think about it, what did we do in the waterfall? So this is unfortunately, sadly, no design, and that's a disaster. So what is the problem with waterfall? We did big upfront design, and if you really think about it, what is wrong with big upfront design? I want to say what's wrong is not the design. What is wrong is not even upfront. The real problem with big upfront design is that word big. And right now, what we are doing is we are doing no design, which is a disaster. So I want to do enough upfront design, and enough upfront design says, I'm not going to jump into it without thinking, but I'm not going to spend a lot of time thinking about it. Also, it's a balancing act. So I want to do enough upfront design to get enough understanding of what I want to do. This is where the strategic design really comes in, where I'm going to do enough upfront design, not a big upfront design, and then I get into the tactical design along with coding using the test-first development or test-driven development. So design is not something I want to ignore. It is something that I have to really continuously evolve on software projects. So that is where I think this comes in really handy, is during the tactical design aspect of things. So we want to talk about some core design principles. Let's start with the very first principle I want to talk about. This stands for, the Dri Principle stands for don't repeat yourself. So this is probably one of those principles I would argue is much needed in our industry, because this is a problem we still continue to face. When developers write code, we end up duplicating so much effort in what we actually do, and that becomes enormous pain in maintaining software. Now, let's talk about the Dri Principle. This was written by the pragmatic programmers in the book Pragmatic Programmers, and this basically talks about two things. One is, of course, duplication of code, but it's more than that. It is a lot more than that. So it actually talks about duplication of effort. So duplication of code is also duplication of effort. But duplication of effort is not always duplication of code. We really want to keep track of the duplication of effort as well. So what does it mean by duplicating code? Well, that's very easy. We've all seen that. People copy and paste code in different places. Sometimes it's even worse. They copy and paste code and change it so slightly different that you don't really see that it's copied and pasted. And we kind of learned this in school, right, in colleges. Because the professor wants us to do this, everybody wants to submit the assignment, so we all copy and paste it, but change enough so that the professor doesn't see it. Well, then we carry that practice to industry eventually, right? And then we have this copied and pasted code everywhere. That's not fun at all. But it's not just copied and pasted code, but it's duplication of effort. For example, let's say you're on a project where you make a change to the schema. Once you make a change to the schema, you're going to go change a DAO object. Then you're going to change the controllers. You're going to change the view. You're going to change a few other classes. Well, guess what we did? We did not duplicate the code. But if you really think about it, this one change replicated through the system, well, that's most likely a duplication of effort after all. And when we duplicate effort, it becomes expensive to maintain software. If that kind of effort is carried through the system over and over and over, you realize very quickly you are making a change here, and then that ripples through the system, and then a few weeks later, you're making another change which is very similar, and that again ripples through the system. This is a sign where we are duplicating the effort every few weeks. And when you go to a developer and say, we want to make this change, they sigh and say, okay, now I got to make all these stupid changes again. And they sit there and keep changing things. This is a sign of duplication of effort on projects. So the Dri Principle says every knowledge, and if you really think about it, we are knowledge workers after all. So it says every knowledge in a system. So when we are dealing with systems, we are knowledge workers. We implement decisions. We implement validation rules. We implement domain rules. We implement so many things in the system that are pure capture of knowledge in a system. So it says every knowledge in a system should have a single unambiguous, so ambiguous, a representation. So an authoritative representation, how about that? So authoritative representation. And this essentially nails what the principle is really saying. It says every knowledge in a system should have a single unambiguous authoritative representation. If you are modeling a system, if you're building a system, I'll give you an example from my experience. You know, they say experience is where you can make all your mistakes before your luck runs out. And what do we call as experience is, you know, how many mistakes have you made and survived it, right, without getting fired? You come borderline to get fired, but you escape being fired, right? That's what experience is. If you make a terrible mistake, you get fired, but you come close to it, and they're like, okay, don't do this again, and they let you survive, right? Well, this was one of my experiences where I had, I had a system where the backend would fail and crash if a certain input was given to the backend. And I really didn't want this backend to crash, so I went to the developers who maintain the backend, and I told them, hey, could you please fix it? And to no luck, no love from them. But I really didn't want people to enter this data in the front end and see the backend crashing. So in my desire to make sure this doesn't happen, I had put logic on the front end. When user entered this nasty data, it would say, sorry, we don't support it. Well, a good 6 months went by, and one of the developers who is maintaining the backend system fixed that particular issue, took a bit of kindness and said, I'll fix this. And then he goes to the front end, enters this data, and the front end says, no, I won't allow you to do it. So he filed a little bug saying the front end does not allow this, but the back end now supports this particular data. Well, it actually took us many weeks to fix it, because in my eagerness to prevent this problem, I had gone wild and implemented this code throughout the front end in various places. And we had to discover these places to remove this particular logic, and that proved to be really expensive. I learned my lesson the hard way. Well, a better thing could have been to really isolate that logic into one class or one function, and then call that from multiple places. So when the time came to remove it, would have removed it in one single place. So we see this often in software systems where people duplicate it. In fact, duplicating things becomes so natural we don't even realize it most of the time until somebody says, why are you duplicating it? I've actually caught myself duplicating code quite often, and it's a shame when I do this and I put my head down and kind of scold myself a little bit. But that's something we do quite often. But the question really is, why should I not duplicate? Why should I create a better design? And I've got only one good reason for it today, and that reason is, if you create a better design, the future you will thank you. There is no better reason, in my opinion, because usually the future me is cursing me, along with my colleagues, of course, right? But if you create a better design, the future you will thank you. This happens very rarely to me, but when it happens, it feels really good. You're looking at this code and it's like, I don't know what you were thinking that day, Venkat, but good job, right? And that's when you know that you've actually done a good job in the past, and now you're not repenting for it. But a lot of times you're like, what were you smoking that day when you wrote this code? And that's how we feel about it. So we want to really create a better design because the future us thanks us, and that's definitely welcome news. But when it comes to duplication, this can be really hard. I was talking to a developer the other day, and he said that he has a system where every 2 months he fixes the same bug again and again and again. I said, oh my gosh, does somebody put the bug back after you fix it? He said, no, this code is duplicated in so many places, we keep rediscovering these places. I said, oh my gosh, how do you feel about it? He said, life sucks when this happens. And then I asked him, when you do find this code duplicated, you do take a few minutes to refactor and remove the duplication, right? He thought for a minute and said, that's a great idea. Well, how do you ever get out of this mess if you don't take the time to refactor it? So that's extremely important for us to refactor. But I'll give you an example of where this kind of becomes very tricky. We always think of Dri as duplication of code, but it's not just code, it's duplication of effort, but sometimes it's really hard to see what that really is. So to give you an example, I have a client who has a fairly a complex system, and about a year ago, or maybe a year and a half ago, all their validation was on the back end. So this was a Java-based backend, but it could have been any language on the backend, but all their validation was on the backend. And about a year and a half ago, their users started complaining. There was a very large amount of validation that happens. Well, what they have to do, the user has to do, is come to the front end and create a boatload of data. And when they finish creating all this data, they would click on a submit button. The data goes to the backend, goes through validation, and it would spit back a variety of these error messages. And the users would have to go through all the errors and fix it and click on the button again, only for it to come back and spit a lot more. And by the time they go through and fix all these errors, it's a lot of effort and time for the users. So they complained and they said, we really want a better way to handle this. So eventually they said, what if we do the validation on the client side? So as they're entering the data, we could do validation right away based on what we know so far. Seemed like a great idea. Well, the minute they decided to do the front-end validation, literally what happened was their JavaScript developers went to their Java developers and said, give me the code. And they took the code and removed all the type information. I mean, that's how you go from Java to JavaScript, right? So they removed all the type information, and they started plugging this into the UI. And of course, now you have UI front-end validation. This worked really well for about 6 months. After 6 months, they started getting bug reports that said, this data was accepted by the front end, but fails on the back end. This data was accepted on the back end, but it fails on the front end. Now they are fixing all these errors that is purely a discrepancy between the two versions. I mean, you could shrug your shoulders and say, this is life in the big city, what can I do? The back end code is Java, the front end is JavaScript. After all, it's 2 different languages. But if you really think about it, it's exactly the same validation on both sides, but it's duplicated. And this is something we should avoid because, as you can see in this particular example, that knowledge of validation should have a single unambiguous authoritative representation. In this case, it doesn't have a single representation, it has two representations, and both of them are trying to claim authority over one another, and there's a discrepancy here. So what's the right solution? Well, one solution in this case would be to really capture that logic on the back end. There are two solutions actually. Capture the logic on the back end and then do a code generation for the front end. I know a lot of us don't like code generations, but there are places for it. And you keep the logic in the back end, but the code for the front end gets generated from it. So yes, there is a duplication at runtime, but there is no duplication at the source code level. An alternate approach would have been to really do the validation using AJAX calls. So when the user is entering the data, it could instantaneously send a request to the back end, do the validation, and come back. It appears to be a validation on the front end, but actually is a validation on the back end that is done through AJAX. That would have been another alternative, not to duplicate the code. But the most important thing at this point is we should really consider not duplicating the code. But I also want to emphasize one thing very important here, because we tend to overlook that. How many times you hear people say, my boss will not give me time, my company doesn't support me. But you have to keep one thing in mind. Management has no clue, right? I mean, in all honesty and seriousness, they don't have a clue. Their job is already very tight to manage the projects and the budget. They have no visibility to what you are doing at the code level. As a person writing the code, you are the professional. If you don't make the right decisions, absolutely no one on earth can make that decision for you. So this is something that's completely in our hands. This is not where we throw our hands up and say, I had all the good intentions, but my company doesn't support it, because the only people who ever have an opportunity to make these decisions is people in this room, right? And if we don't do this, we can't complain the management doesn't let us do it, because they don't even have a clue what these things mean. And so it is our professional responsibility to actually act on these things, because we're the only people who are capable of doing these kinds of technical decisions. We can't really push it away to blame somebody else. It becomes our core responsibility. So that's basically what the Dri Principle says, is we should really try to focus on not duplicating the code. And sometimes people argue, oh, in a world of microservices, we don't want to really follow this principle because, well, microservices needs to be able to evolve without affecting one another. We don't want things to be brittle. But it's important to keep in mind, let's not confuse duplicating binary versus duplicating source code. In a environment where you have microservices, you don't want to have a binary dependency because that makes things brittle. So you want to duplicate the binaries, but let's not let that convince us that we want to go rampant and duplicate the source code, because that eventually leads to unmaintainable software as well. We got to be very careful. But just because we want to follow the Dri Principle, it doesn't mean we have to overly complicate code. We don't want to create abstractions that are not needed. So we have to really truly understand where the duplication becomes a problem, and then take effort to address that problem. So in other words, don't work in theory, but work in practice and find out where this is a concern and then address that concern. That becomes extremely important. So moving forward a little bit from the Dri Principle, I want to talk about the so-called Yagna Principle. Well, Yagna stands for you aren't going to need it. Now, this is one of the things we do quite often that is very shocking. We tend to write code based on what we think we need, not based on what the application really requires. We do this as programmers a lot. When we're sitting and writing code, we kind of let our thoughts flow through, and we put stuff in the code because, after all, we would need it, right? But does the application really require it? You may have taken an effort to implement this feature. Maybe you took an effort that cost $50, but maybe it has only a 5-cent value to the business. And why do we want to put more effort building something that's not really needed? So ask the question, do I really need to do this? I've seen code where people create interfaces. And I look at this and say, why do you have an interface here? They kind of look at you as like, are we not supposed to create interfaces? Because that make the code extensible. And extensible for what? I don't know what the extensibility is, but we have to create this abstraction. Get rid of the interfaces you don't need, bring them in when you actually need it. Or I see people doing stuff that's not even in the requirement. The other day I saw people doing logging in various parts of the system, but nowhere did the application require logs, for example, and yet we do this quite often. I've seen people create XML documents and send them across. Like, why are we creating XML document? And they will tell me because it makes the code extensible. But the software did not require any such extensibility at all, and yet people are writing code for it. So the question really is, do we really need to implement this piece of code? I've actually highlighted a lot of code during my review and say people to remove it because you don't need this code at all. We are wasting our time and effort creating the code we just don't really simply need. And this is something we got to be very careful about. Now, I tend to see that the programmers often create as much code as restaurants serve food. I live in the US, and if you know about restaurants in the US, you order food, you get a lot of food. When I come to Europe, I feel like I'm starved actually because of the food I'm being given. I'm used to it. And I look at the place like, where is the food? There's a lens to look at the food, right? There, you have a big plate of food. Sometimes when I go to restaurants over there and I order food, they give me so much food. I would look at this and say, why are they giving me so much food? Are they trying to tell me something I don't know? Is this my last meal? I wonder. So they tend to give me a lot of food. And programmers are like that. They tend to write a lot of code that's really not needed. So we have to ask the question, do we really need this code and implement it? If it's going to cost the same amount of money to create it now and same amount of money to create it later, I would rather create it later if I don't have to create it now. Well, the beauty of postponing it is I can spend the time doing stuff I need to do now than doing stuff I don't need to do now. That's one of the biggest benefits you get out of this. And if it's going to cost you the same amount of money, well, do it later. If it's going to cost you less later on, you don't need it right now, better to wait. But what if it's going to cost you more to do it in the future than it costs right now? Well, then ask the question, what's the probability that you really need it? If the probability is extremely high, implement it now. Otherwise, postpone it. But this is really easy to forget. I remember one experience where I was pairing up and coding with another developer. And as we were coding, we had written the test, we are implementing the code to pass the test, write a bit more test, implement the code to pass the test. But as I got into the code that I was trying to implement, as we were pairing up, while writing the code, I said, oh, by the way, we should handle this condition, and brr, I'm writing some code right there. He elbows me and says, oh, excuse me, Venkat, are you not supposed to just write minimum code to make this test to pass, and then write another test, and then come back and implement the code for it? I'm like, I know, I should do that. That's the right thing to do. But I'm a human as much as anybody else is. I try to sneak in code. So I removed the code, and I wrote minimum code to make the test to pass. Then I switch over to the test, and I write that negative test for that particular condition I want to check. And as soon as I wrote the test, I ran the test, and I was pretty shocked to find out that the test actually passed. The fellow developer who's sitting next to me said, are you that good, Venkat, that you sneaked in and wrote the code so quickly when I looked the other side? It's like, no, you told me not to write it. I'm writing the test, but I don't know why the test is passing, so we flip the code up. We both are staring at the code. How could this actually pass? And that's when we discovered that the library that we were using was already handling that condition. And here I was being silly, trying to write code for what has been done already. And that was a lesson I learned. And of course, the test is important because tomorrow we could use a different library, and that library may not be handling the situation, and the test should tell us that we need to really handle this particular condition. So the test is very important, but the code was totally useless at this point because the library is already handling it. I shouldn't be implementing that code after all. So when you're implementing features, ask the question, do I need to really write this code? I'm going to say, this is what we call as experience. You stand by the door and you look at this very young developer who just graduated from college and he's in the first job, and 8 in the morning, 8:30 in the morning, whatever time it is, you ask the developer, where are you going? And the developer says, I'm going to go write all that wonderful code and change the world. Just wait for 15 years. Ask the same developer when they are going to work and say, where are you going? And the developer says, I'm going to go to work and remove all that code and change the world, right? This is what is experience. You learn not to write as much code. The less code you write is better. For one, the code you don't write has the fewest bugs in it. Hands down, right? You cannot have any less bugs in code than the one you didn't write it. If you don't write a piece of code, you don't have to support it. What a great idea, right? So you don't have to be sitting at work late in the evening fixing the damn code because you didn't write it. You don't have to support it. And of course, then you focus on writing the minimum code. And that is one of the most important things is how can I get done my work by writing minimum code? I'm not suggesting you be lazy, but you should try to really minimize what you write because then it's less code to maintain and more value for less is actually a good thing. So that's basically what the Yagna Principle says is postpone. But sometimes the developers get really apprehensive when I go to them and say, don't write it now. So I put this little yet in the end, and that makes a world of difference to them. So when I say you're not going to need it, they get angry. But if I tell them you're not going to need it yet, they're much more willing to listen. Hey, do you think I can write it tomorrow? Yeah, maybe. And then just say the same thing the next day also and keep postponing until the project got released. And they come to you and say, we just released it, but what about all these other things I didn't do? Well, nobody cares. Why do you want to implement stuff that nobody wants? And you can eliminate doing stuff. So it really comes to the economics in this case to say, I want to minimize that. Well, the next principle I want to talk about here is called the single responsibility principle. It also is a principle that's very troubling for me because it turns out a lot of us don't have a clue what that actually means. I've heard people tell me, if you write an if statement in your code, you're failing single responsibility. Or people tell me if you're taking 2 parameters, you're failing single responsibility. And how could this be so bad that you can just say, oh, if it is this, it's a single responsibility failure. This actually prompted me to think about this a little bit further because a few months ago, I was looking at, we were looking at an example code, and the code did something like that. It said list of shape, for example, just as an example here, and then it said shapes equal to get shapes, for example. Then we had to process the shapes, so process shapes, and then it said display shapes. So it was kind of code like this. And this was all within one function, by the way. And the developer, one of the developers looked at this and said, oh, this code fails single responsibility. And I was like, wow, how could this code fail a single responsibility? And he said, because this code is doing 3 things. And that's when it dawned on me that we don't really know what single responsibility really means, because if that failed single responsibility, you would never be able to implement software systems after all, right? And everything is going to do one thing and nothing will come together to do stuff. And then how do you build a system to work actually? So it really dawned on me, we don't really understand what single responsibility is. We are trying to kind of put arbitrary things together, and that's really frustrating. So how do we really know what single responsibility really is? We'll come back to that in just a minute. But let's talk about long methods. We all have seen long methods. We have all worked with long methods. But let's talk about long methods. Well, my first question to you is, raise your hand if you think long methods are a good idea. Well, not a single, well, one person. That's always one person, right? So that is, yeah, I was looking for you. There's usually one person, and you can ask them why long methods are a good idea. They probably tell you because it gives you better performance, right? They're not entirely wrong. They're actually right. But the last time they were wrong was when Nixon was the president. A lot of things have changed since then. We got better compilers, better architecture, better tools. So those rules don't really hold strong. But let me ask you a different question. How many of you see long methods at work today? Okay, slowly the hands go up. The reason why slowly the hands go up is some people are actually in denial. This is not happening to me, right? So yeah, so we all see, almost the entire room raise the hand. So I know one reason. You didn't do it, right? Because you just said a few minutes ago, you don't believe long methods are a good idea. So you're obviously not creating long methods. The people who are creating long methods are at work today, making those methods longer as we speak, unfortunately, right? So why is this the case? But let's come back to that in a minute. Why is long methods such a bad idea? Let's put some reasons for it. What are your reasons? Why are long methods such a bad idea? Oh, difficult to read. So here's a way to think about it, right? You have a long method. What do? You start reading, and you're loading all that into your mind. And then your mind is kind of trying to throw a Stack Overflow exception, right? And then you're like, stop, more, more, more. And then it's like, are you done? No, I got more. Well, the other day, I'm a consultant, so I go work in different companies. So the other day, one company that I was working with wanted me to, review the code so I can help fix some problems. And I naively started reading the code, honestly, right? Brrr, I'm reading it. After a few minutes, I'm like, I've read enough. How much more is there? And I didn't know. So I put my finger on the down arrow. Brrr, it keeps going. Okay, that doesn't help. Take the hand off, page down. And that's still going. That didn't help. Then I went all the way down, and I'm doing the curly brace matching. And then I'm trying to do a little math to find the difference. That's when you know this has gone really bad. So if you want to know a real-world analogy to how it feels to read a long method, don't try this at home. This is not going to be fun, but imagine this. Take somebody and dunk them underwater. Hold them down in the water. After a few minutes, take them out. And then it's like, how's it going? Put it them again, right? That's how it feels to read a long method, because you're down there, and then you're like, I'm holding my breath, I can't handle this anymore. And the method says, I've got more for you. And this is why it's really hard to read code, because you're trying to load all of that into your head. It's incredibly difficult. Okay, what else is the reason? Difficult to change. You try to change it, what happens? It's very fragile, isn't it? You change something and it begins to break. It's really hard to put that together, so that's a problem too. What else is the problem? Say that again for me. Oh, so it is not cohesive, right? It fails SRP, not following SRP. So the code probably doesn't have a single responsibility. It doesn't have a single thing it does. It's not cohesive. So I'm going to say low cohesion. We'll come back to that. What else can we think of? Oh, hard to test. Impossible, yeah, hard to test. How do you test a piece of code that does so many things? The permutation and combination you have to put together is so many, you eventually say, don't worry about it. If it doesn't work, your users will tell you eventually, right? So you don't really spend time testing it. In fact, it's another thing. So it is not cohesive, but it usually has high coupling. You think the code that's long is going to come alone to the party. It invites a lot of other things together. In fact, collectively, these two things together, so good design has high cohesion and low coupling. Look at how these things relate together now. This is diagonal opposite of good design. Good design says high cohesion and low coupling. Long method has low cohesion and high coupling. And so it's terrible in multiple ways, as you can see. There is another problem also with this. The other day somebody said this in a very sad way. He said, long methods become longer. It is so true though, right? If you really think about it. I travel a lot. So when I go home, I always look at my children and say, hey, you are taller than you were before. That's a good thing, right? But you come back to work and say, you're longer than you were before. That doesn't feel good at all, right? You don't want methods to become longer like that. That's pretty evil. Any other reasons you can think of? Say that again for me. Oh my goodness. Unpredictable behavior. Thank you. So unpredictable behavior. So what happens in this case? Well, you are not sure what the code is going to do. And the people who get hired to work on this code, they are not called programmers. They're called victims, right? And that's how you feel when you work on these projects. It's really hard to maintain. Hard to reuse. And how do you reuse? You look at this long function and you're like, wow, what I want is right there in the middle. It says you can't have it, right? And so leads to duplication as well. And you can keep going with this, right? There's so many reasons we can keep putting towards this. But let me ask you a different question. Long method, you said. Put a number to it. How long is your method that you are complaining about? It's long. How much? More than 5. No. What's your longest method? No. What's your longest method? Come on, give me a number. How many have you seen? 900 lines. Anybody else? What was it? Couple of thousand. Put a number to it. 2,000. Anybody else? 65,000. Why 65,000? No, but why 65,000? So somebody said this to me last week, and I asked him, why 65,000? He said, because that's the limit of the compiler, he said. There is hope. There is hope, isn't it? And, how do you deal with code that is that long? How do you deal with code, one function, which is 65,000 lines long, right? How do you deal with that kind of code? Extremely difficult, isn't it? So the point really is, we look at this kind of code and say, how do we really manage these kinds of code? And somebody said, they said the code is too long if you cannot put the entire code in one screen. The minute you say that, somebody says, what's your font size? There is no way to win that battle either, right? And then you're like lowering the font size, putting more in a window. How do you say that? Somebody said 5 lines. Somebody may say 100 lines. Somebody may say 20 lines. Well, that depends on the language as well. It turns out none of these things really make any sense. So to understand what this means, I'm going to give you a different example so it becomes easier to relate to what a long method is. So when you go to work on Monday, don't say a word. Just sit down and work. Your colleague, the one I'm talking about, right? The one who writes long methods. You've told this person a lot of times, don't write long methods. This person doesn't listen to you. So I have a suggestion. Go to work on Monday. Don't say a word. Just sit and work. Your colleague comes to you and says, hey, how was your weekend? You could say, oh, my weekend was great. I went to the park on Saturday, went to the movie on Sunday. But don't say that. Instead say, oh, my weekend. Well, exactly at 7 o'clock, I got into the car, reversed the car out of the garage, took a left turn, drove for 3 kilometers, and then took a right turn, and then drove for 5 kilometers, and then I went in the roundabout, but I missed it, so I went around 3 times. It was really funny. But then I took the rightmost exit, the second exit, by the way, took about another 4 miles. Oh, by the way, there was a beautiful bird, yellow in color, and then I took a right turn. Just keep going like this. At some point, your colleague will say, have you gone mad? You say, no, I've not gone mad. I thought I'll tell you how my weekend was, like the way you write code. So the point really is, people don't talk like that when you communicate with them. What do? We give them knowledge chunks. You said, I went to the park on Saturday, went to the movie on Sunday. Well, your colleague may say, tell me which park did you go to? Well, I went to the park, by the main street. Oh, is it a family-friendly park? Did you take the kids over there? What kind of facilities do they have over there? You are now talking more and more about the park. You don't care about the movie at this point. So the point really is, when we communicate with people, we give them knowledge chunks, and then we let them look into it further. When you're writing code, what are you doing? Surprisingly, we are communicating. We sometimes communicate with the compiler, but a lot of times we are leaving something for the next programmer to come and see the code. So coding is an act of communicating with fellow developers. And if we don't care about them, we can write anything we want to write. But if we care about them and if we want them to understand it, we got to write in these abstraction. So it turns out it really is about slap. No, don't get physical. Don't get physical with your colleagues. I'm not telling you to slap them, but this really stands for single level of abstraction principle. So a long method is not the number of lines of code after all. When you say it's 5 lines, 20 lines, 100 lines, that's not what a long method really is. When you want to know if a method is long, don't look for the method vertically, look for the method horizontally. So you ask how many levels of abstraction you have in this piece of code. The more levels of abstraction you have, the longer the method really is. So in other words, when you look at a method, if all the methods are at the same level of abstraction, it becomes easy for you to follow. But if a method goes from one level to a deeper level, comes down to another level and goes down, you are trying to keep all this in your head, and transitioning from one level to another to come back is what really makes it hard for us humans to keep that in mind. Whereas when everything is one level, it's easy to follow step by step. So this is where it becomes a lot more easier to comprehend the code when all of them is in one single level. So when I talk to developers, they used to say in the past, oh, I don't like short methods. I would say, why don't you like short methods? And they would say, because there are way too many short methods in my program, and it's really hard to follow. And I used to be confused, like, what does that really mean? And now I know what that means. People are taking the length of the method and start breaking it down. That's a disaster. Instead of looking at the length of the method, if you look at the abstraction, there are times when I'm doing code review, I would tell my developers to take two functions and merge them together because those two are in a single level of abstraction. On the other hand, even if the number of lines is really small, I would ask them to break into two methods because those are two levels of abstraction. They don't belong together. So when you look at a level of abstraction, it becomes easier to follow. So for the length of a method, don't look at the number of lines, but look at the number of levels of abstraction. And a good method should follow the so-called compose method pattern, where it's composed of all these calls at one level of abstraction and drill down into the details moving forward. So a good time for us to break. Let's come back in about 15 minutes, and we'll continue with the next part. Thank you.